Hi, Metho 5 students. Hopefully you are ready to start section 6.4, which is solving rational equations. Now, as you solve the rational equations that are going to be up on the board, remember that you also have a handout that contains all of those problems. So be sure you're either looking at that handout on your computer so that you can write them down, or that you've made a copy so that you can be looking at those. I think that'll be helpful. Also, be sure you use the pause button because sometimes I may be finished with the problem and you're not quite finished, and you may want to go back and or stop so that you can be doing the problems at the same time. One other thing, use your book. Use those practice questions that are in your book. Be sure to go over those. It's probably better to go over them maybe even before we do the videos so that you're familiar with the process. Okay, so today's lesson is on rational equations. A rational equation is an equation that contains one or more rational expressions. So remember that this would be a rational expression, this would be a rational expression, so this would be a rational equation. To solve a rational equation, the first thing that you're going to do is to list any numbers that make the denominator 0. The variables cannot equal these numbers. So in our first example, if x were 0, we would get a 0 in the denominator. We don't want that. And so for the first problem, x cannot equal 0. Okay? So our second step is to eliminate the denominator by multiplying all terms by the LCM, the common denominator. And then we'll solve the equation, and then we're going to check our solutions. I'm going to leave the checking to you to do on your own, just because it would take too much time on the video. Okay, so example 1. We have 1 over x plus 3/4 x, and that's equal to 1. So as we're solving this, the first thing that we need to do is to remember that x cannot equal 0 for this. And then the second thing is to find the common denominator so that we can eliminate the denominators. So it looks like 4x is going to be the common denominator. So we're going to multiply each term by 4x. I think I'll do that in a different color. And then 4x, and then 4x. So in this term, the x's are going to cancel out so that you would have 4 times 1, which is 4. In this term, they both have 4x, so that would completely cancel out. So you're left with the 3. And then the last term, it's going to be 1 times 4x, so we get 4x. All right, so on the left, we'll add the 4 and the 3, which gives us a 7, and that's equal to 4x. Then, of course, we would divide by 4. So our solution then is 7/4 is equal to x. Okay, all right, let's look at example 2. So example 2, our denominator is 2x and then x squared. And actually, I'm going to move this x just so it's down in the denominator, because it kind of looks like it's floating there. So 1/2 x plus 3x squared is equal to 1. So it looks like our common denominator is going to be a 2 and then x squared. So we're going to multiply each term by 2x squared. So we've got 1/2 x, and then we've got plus 2x squared times 3x squared is equal to 1 times 2x squared. Okay, so in this term, the 2x would cancel out, which would just leave us with an x. So x times 1 is x. In the second term, the x squared would cancel out, which would just leave us with a 2. So we'd multiply the 2 times the 3 to get the 6. And in the last term, 1 times 2x squared is 2x squared. Okay? Now looking at this, I can see that this could be a trinomial. And by looking ahead, it gives me an idea of how to continue solving this. So this x squared makes me think, you know what? This could be a trinomial and I could probably factor it. Now, because I don't like the leading variable being a negative, I'm going to just subtract the x and subtract the 6 and then move them to the other side. Okay, so now we have 2x squared minus x minus 6. And this, of course, would just be 0. So now we're going to factor. I'm going to move this up a little bit. Now we're going to factor. To begin with, we would start by multiplying 2x squared times a negative 6. So 2x squared. I think I'll move this down too. Join your friends. Okay. So 2x squared minus 6 would give me a negative 12x squared. And so now what I'm looking for are two numbers that are a product of a negative 12 that would also give me a sum of a negative 1. And so of course 3 times 4 should do that. So 3 times 4 is 12. And if the 4 was negative, then that should give us our numbers that we're going to use for factor by grouping. Okay, so I'm going to copy over the 2x squared. Instead of the negative x, I'm going to have a negative 4x, and then I'm going to have a positive 3x, and then minus 6. Okay, I'm going to erase this just so it doesn't become confusing. There we go. So now when you're factor by grouping, remember you look at the first two terms, factor out a common factor, look at the second two terms, factor out a common factor. So for the 2x squared and the 4x, the common factor would be 2x. And then we would need to multiply by an x, and then this would be 2. So we've got x minus 2. Here we have a positive 3x and a negative 6, so that means we need to factor out a positive 3, which would give me x minus 2. Let me move that up. Oops. Okay, so we group together the common binomial factor x minus 2 and the 2x plus 3 in a second parenthesis. So remember, we're looking for solutions. So what we're going to do is we're going to, whoops, that didn't work. We are going to solve x minus 2, and we're going to solve 2x plus 3. So x minus 2, if we were to add 2, then x would equal to 2. And then here, if we would take away 3, and then divide by 2, then x would also be equal to a negative 3/2. Now let's go back up to the beginning, which I think I failed to do. I did. We had 2x and x squared is equal to 1. And so to solve this, to figure out what the denominator, what number the denominator would be multiplied by to get a 0 in the denominator, is just going to be a 0. 2 times 0 would be 0, and if it was 0x squared, it would actually be 0 also. So our solution cannot equal 0, but it could equal x is equal to 2, and it could equal x is equal to a negative 3/2. Okay, and I'm not sure if you can see this. Oops, let's move this over. There we go. Okay, that looks like you can see that. Okay, so x is equal to 2 and x is equal to a negative 3/2. So that is our solution. Okay, so our next problem is 6 plus 2x over x minus 3 is equal to 6 over x minus 3. So the common denominator is going to be x minus 3. This is kind of an easy one to figure out. And if we would also need to look at what number would x need to be to make the denominator 0, and of course it would have to be a positive 3, right? 3 minus 3 is 0, so if x were 3, then we would get 0 in the denominator, and we don't want 0 in the denominator, so 3 cannot equal x, or x cannot equal 3. I don't think you can see that though. There we go. X cannot equal 3. Okay, I'm going to move that up just so it's out of our way. Okay, so what we're going to need to do is to multiply each term by the common denominator, x minus 3. And so, of course, when we do it here, that cancels out. When we do the same thing here, the denominator cancels out. And here we would have 6 times x, which is 6x, and 6 times a negative 3, which is a negative 18. So we have 6x minus 18 plus 2x is equal to 6. We can add the 6x and the 2x together to get 8x. So we've got 8x minus 18 is equal to 6. Now, this is where you kind of have to look ahead. You need to look to see, can I solve this without factoring, or do I need to factor? And so I'm looking at this thinking, let's see, if I were just to add the 18 to the other side, I'm going to get 24. And then if I were to divide by 8, 24 divided by 8 is 3, so I get x is equal to 3. So that was the easiest way to do it, so I really didn't need to factor this one. So x is equal to 3. I go back and look at our solutions. Oh, rats, x can't equal 3. So for this particular problem, your solution is no solution. Okay, all right. Number 5. Okay, so for this one, x plus 5 is the denominator. So if x was a negative 5, negative 5 plus 5 gives me 0. That would mean we can't have a negative 5 for a solution of the denominator because it would give us a 0. So here x cannot equal a negative 5. Okay, I'm going to erase that because it's kind of in the way of solving the equation. And I think I'll move this up. There we go. Going up a little more. Okay, so our common denominator, since both the denominators are x plus 5, that's going to be the common denominator. So we're going to multiply each term by x plus 5. So because this is the same, that cancels out. So the only thing I'm really multiplying x plus 5 by is the 1. So I have x plus 5 plus 2x is equal to a negative 10. I combine any like terms, so the x and the 2x would give me 3x. So we've got 3x plus 5 is equal to a negative 10. And again, this is where we look to see, can we solve this without having to factor? And it looks like we can. If I were to take away the 5, I'm going to have a negative 15 is equal to 3x. And then if I divide by 3, x is equal to a negative 5. So if x is equal to a negative 5, let's see if that's what we decided it couldn't be. Sure enough, x cannot equal a negative 5. So for this one, we have no solution. Our next problem, we have y squared over y plus 2 is equal to 4 over y plus 2. So how would I get 0 in the denominator? Well, if we had a negative 2 plus 2, that would give us 0. And so for this particular one, y cannot equal a negative 2. Okay, so now that we know that y cannot equal a negative 2, it sure looks like y plus 2 is our common denominator. So we're going to multiply both sides by y plus 2. And of course that cancels out. So we've got y squared is equal to 4. And so I'm looking ahead, and I noticed that if the 4 were on the other side, then it would be y squared minus 4 is equal to 0, which is factorable as a difference of squares. And so I'm going to factor it to solve. So I'm going to have y minus 2 and y plus 2. So now I have two parentheses to solve. Whoops. Going to solve them right where they are. So to solve this parenthesis, I would need to add 2. So I've got 2 is equal to y. For this parenthesis, I'd have to take away 2. So I have y is equal to a negative 2. So my two solutions are 2 and a negative 2. And I go back up to the beginning, and I remember that y cannot equal a negative 2. So my only solution then would be y is equal to 2. All right, then example 7. So for example 7, we've got x squared over x minus 5 and 25 over x minus 5. And so again, this is a pretty easy one to see what the common denominator is. It's x minus 5. So those would cancel out. So we've got x squared is equal to 25. And again, if you look ahead, you can kind of remember that 25 is a perfect square, x squared is a perfect square. So if I were just to subtract the negative 25, so that I have x squared minus 25 is equal to 0, this of course is going to be a difference of squares. And so I will solve the difference of squares with x minus 5, x plus 5. And then I'm going to solve each parenthesis. So x minus 5 would be plus 5. 5 is equal to x. Minus 5 gives me x is equal to a negative 5. So those are my two solutions. But are they solutions? If I go back to this, which I'm realizing I didn't check first, but if we were to solve this original equation with just the x minus 5, if we were to solve this, if it was a positive 5 minus 5, that would give us 0. And so x cannot equal a positive 5. So since x cannot equal a positive 5, This is not going to be a solution, but this will be our solution. X is equal to a negative 5. Okay. All right, let's look onward. Okay, so for example 8, we have a function. And the function says the function of x is equal to 2x minus 6x. If f of a is equal to 1, what would our solutions be? So if f of a is equal to 1, that means we would rewrite it as 1 is equal to 2x minus 6 over x. Okay, so as we solve this then, the denominator is x, so that means our common denominator is going to be x. So we're going to multiply all terms by x. So we have x on the left, x times 1 is x. X times 2x is 2x squared, and these x's would cancel out. So we have x is equal to 2x squared minus 6. This sure looks like it could be a trinomial if we were to move the x to the other side. So I'm going to do that, and when I move it, I'm going to put it in the middle, because with a trinomial, that would be writing it in the descending order. So now we've got 2x squared minus x minus 6. Okay, so remember to solve trinomials, we start by multiplying the first term times the last term. So 2x squared times a negative 6 would be a negative 12x squared. Now I'm looking for a product of a negative 12x squared, which would be a sum of a negative 1. And so we've got some possibilities. 3 times 4, 6 times 2, and 1 times 12. But the only one that would give me a sum of a negative 1 would be 3 times a negative 4. Okay, so if this were a negative. So now I'm going to factor by grouping using the 3x times the negative 4. So I copy over my first term. I'm going to go ahead and use the negative 4x next. Then I'll use the positive 3x, and then I'll use my minus 6. We're going to look at the first two terms, and we're going to factor out a greatest common factor, which looks like 2x. So we factor out the 2x. So we've got x minus 2. Then we look at the 3x and the negative 6, so we're going to factor out a positive 3, which gives me 3 times x minus 2. So the binomial common factor is x minus 2. Then we have the greatest common factors, which we'll also put in a parenthesis. We'll solve these two parentheses individually. So x minus 2 is equal to 0, so we could add 2. So x would be equal to 2. So we've got one solution there. Then we would also do the same thing for 2x plus 3. Okay, so we would take away our 3. So we've got 2x is equal to a negative 3. Then we would divide by 2. Let me lift that up. So x is equal to a negative 3/2. So let's go back to the original and see if we had anything that x could not equal. X could not equal 0 since we've got a negative 6 over x. It would just be 0. So we have two solutions. Both of them are good. So we've got a negative 3/2 and we have a 2. And there is our set of solutions. Okay. So the next part is the you try it's. And I want you to try it, and I want to give you enough time to try it. So the second video for 6.4 will say 6.4 you try it's. And so after you begin solving these, I want you to access that second video. That way you can check your answers. Okay, so I'll see you in a few minutes on the second video, or I won't see you, but you'll see me. All right. Good luck.